This is the second video lesson explaining how to prove or verify trig identities. So remember that it is not the same as solving. If we are proving that two trigonomic expressions are equal, we cannot assume that they are equal and cross over that equal sign. So when we do this, we're going to work down one side only and then make that one side be identical to the other side. So it's easier if we work on the more complicated side first and then leave the other side alone, because it's easier to go from something more complex to more simplified than the opposite. When we simplify one of the sides, we're going to do that by changing sines and cosines. So take your trig expressions, change them into terms of sine and cosine. If we see any Pythagorean identities or variations of them, we're going to substitute. We might also factor. We could, if we had fractions, combine them with a least common denominator, and then also multiply binomials by the conjugate. So these are the 5 steps we're going to look for to help us prove or verify the identities. I would say that the left-hand side is more complicated than the right. So I'm going to take the left-hand side and show that it's equal to cotangent squared. So if I think back to my Pythagorean identities, because there's a 1 and a trig function that's a squared, I'm going to take a look at my Pythagorean identities and see if that's any of them. So we do have one that's 1 plus cotangent squared is equal to cosecant squared. So that's what I have. I have 1 plus cotangent squared. So 1 plus cotangent squared I can substitute with cosecant squared. So now I have cosecant squared times cosine squared, and now I go from there. Now I can change them into terms of sines and cosines. So cosine squared will remain cosine squared, and cosecant squared is the same as 1 over sine squared. So then, if I multiplied the numerators with the numerators and the denominators with the denominators, I get cosine squared over sine squared. Since I know that cosine over sine is cotangent, and I have 2 of them, both of them are squared, then my final answer is just cotangent squared, which is what I had on the right-hand side. So remember, we draw our line and we put QED for Latin, representing that we just demonstrated that. For this next example, I would say that the left-hand side is more complicated than the right-hand side. I'm going to start off by changing the left-hand side into terms of sine and cosine, because I have a lot of trig identities and some of them might cancel. So tangent is the same as sine divided by cosine, and cotangent is the same as cosine divided by sine. Cosecant squared is 1 over sine squared. So now that I have a complex fraction, I'm going to look at the common denominator of all of my little fractions and then get rid of it. So the common denominator of all 3 little fractions would be a sine squared times cosine. And if it's helpful to put that over 1 so you don't make any mistakes, definitely do that. So I multiply this to the numerators of all of my little fractions. So sine squared cosine over 1. So now these cosines are going to cancel, leaving me with sine cubed. And these sines will cancel one of them, leaving me with a sine cosine squared. And the denominator, sine squareds cancel, leaving me with a cosine. So now I have gotten rid of my complex fraction, and if I'm looking to get closer to the right-hand side, I can't do a common denominator. I changed the sines and cosines. So now what we have left to check, I could see if I could factor the numerator. So they each have a sine in common. So if I take out a sine, I'm left with sine squared plus cosine squared divided by cosine. And this, since there's squareds and addition, looks like one of my Pythagorean identities, which it is. We know that sine squared plus cosine squared is equal to 1. So since that's a Pythagorean identity, this whole set of parentheses is just equal to a 1. So now I'm left with sine divided by cosine, which I know is the same as tangent. And that's what the right-hand side is. So QED, and we are all set. For my third example, I think the right-hand side is more complicated than the left-hand side. So I'm going to start there. I see on the right-hand side that they both have a secant squared in common, so I'm going to factor out a secant squared from both terms, which is going to leave me with that. And then if I look at what I have and what I need to have, I need to change these secant squareds into tangents somehow. So if I think to my Pythagorean identities, the one I'm probably going to use is tangent squared plus 1 is equal to secant squared. So this secant squared right here, I'm going to change to tangent squared plus 1. And this secant squared, I'm going to do the same thing. Change it to tangent squared plus 1. So if I combine like terms in this set of parentheses, I'll then have tangent squared minus 1. And then if I wanted to get to my tangent to the fourth, I'm going to see if that will happen when I FOIL this, since I have two binomials. So if I do tangent squared times tangent squared, I'll get tangent to the fourth. Tangent squared times negative 1 will be minus tangent squared. Positive 1 times tangent squared will be positive tangent squared, and 1 times negative 1 is negative 1. So then the negative tangent squared and positive tangent squared will cancel, leaving me with tangent to the fourth minus 1. And that is what my left-hand side is. So QED, we are done. For this last example, I would say the left-hand side is harder than the right-hand side. So first I'm going to see here that tangent squared could be a Pythagorean identity. And the reason I'm looking at that as an identity is because I have secant on the bottom and secant over on the right-hand side. So if I think and I look at my Pythagorean identities that contains tangent squared, I have tangent squared plus 1 is equal to secant squared. So I'm going to substitute tangent squared as the numerator with secant squared minus 1. So if I move this 1 over, I'd be subtracting it. So then the reason I'm doing that is because I see that I have squareds and a single on the bottom. So if I'm trying to get it to be the right-hand side, I could factor this numerator because it's a difference of squares. So if I did a difference of squares to factor, I would get secant plus 1 and secant minus 1. And then, since they both have a secant plus 1 on the top and the bottom, those cancel out, leaving me with secant x minus 1, which is the right-hand side. So sometimes it's a lot easier than you think. You need to look at what you have and what you need to have so that you can figure out how to tweak your problem to make it look like the other side. And then don't forget your QED.